So we're talking about another Leetcode problem. This one is an easy one, but it just needs a bit of thinking. That's what I'm doing in this channel. I'm trying to help you learn how to think about the problems rather than give you the solution. The solution can be easily taken out of ChatGPT and the likes of that. But in the age of AI, what really people need is how to solve problems, how to think mathematically. I know that a lot of you don't really enjoy doing things mathematically, but that's the reality of the age of AI. So I will try my best to provide a number of thoughts, a number of ways of thinking about problems, but let me know which one you really find that resonates with your way of thinking. Tell me if you were thinking the same thing, or if you have a better idea. That also really helps me create a community of people that I can help. A couple of people have reached out to me on LinkedIn. I have connected with them and I am helping them in the background. So do that. Subscribe to my channel, like my videos, leave a comment. Let's make that connection, and we don't know where that takes us. So let's start number 13, which is called Roman to integer from memory. Let me just check. I'll just drop my face small down there. Yeah, that's called Roman to integer. As you can see on my screen, I have two of them. One of them is in white, that's Leetcode, and this one in black is a Jupyter notebook that I have prepared for me to be able to explain the problem to you. Let's see what the problem is. Roman numerals, back in time, people used to show numbers with Roman numerals, if you didn't know that, are represented by 7 different symbols. So we use I, V, X, L, C, D, and M. I represents number 1, V represents number 5, and rest of that you can see on the screen. So that's what those symbols and values really mean. We will need that, and think about this just off the bat as a guideline. You will need this guideline in your code. Otherwise, Python will not know I equals 1, V equals 5. Python does not know that. You need to tell it. So that's step number 1. So I will call it out in my notebook. Step number 1, define what numerals mean, maybe not in Python, to Python. So we will have to tell Python what that is. Let's read the rest of the problem, but I can see that we have to convert from Romans to integers with a bit of help. For example, 2 is written as II in Roman numeral because 1, 1 is 2, just 2 ones added together. 12 is written XII, and that is 10, 1, 1, which is 12, which is simply, the math is on the screen. The number 27 should be XXVII because you've got 10, 10, 5, 2, 2, sorry, 1, 1, and that makes it 27. Roman numerals, and this bit is pretty important, are usually written largest to smallest. I think that's true because 12 is written XII, so 10, 1, 1. We don't write it 1, 1, 10. However, the numeral for 4 is not I. Instead, the number 4 is written IV. Well, we just said that it has to be largest to smallest, but I can see that it is 1 and 4. Let's see what's going on there. Because the 1 is before the 5, we subtracted, making it 4. Oh, okay. So that because this is IV, we say V is 5, but because I is coming before V, then we say 5 minus 1 instead of adding them together. All right, let me just write that down on the screen as just a guideline. So IV equals V negative I, which equals 5 negative 1, which equals 4. So just keep that in mind. This is different to the usual rule, but the same principle applies to the number 9. Number 9 is also IX. All right, let's write that one down as well. IX equals x minus I equals 10 minus 1, which equals to 9. Okay, these are special cases. That's okay. There are 6 instances where subtraction is used. Okay, we have the rule here. I can be placed before V, so 1 can come before 5, and X to make for a 9. Okay, that's 2 of them. X can be placed before L, which is 50, and C, which is 100, to make 40 and 90. Okay. And C can be placed before D, which is 500, and M, which is 1,000, to make 400 and 900. So here is the task. Given a Roman numeral, convert it to an integer. Okay. Now, the thinking is here. If I am given some Roman numeral and it starts with a bigger number than a smaller and smaller, that's fine. I can use my guidebook, which is my step number 1, to calculate what that equals to. That's easy. But if it is a special case and it starts with a smaller Roman numeral and then the larger one, and you can see that this is going to be my checkpoint, then I have to do subtraction, not addition. first, let's worry about addition, and then we will think about subtraction. So first things first, let me write down the steps. This is just a matter of guidance. Step number two will be for me to define how the normal principle of addition works. So if I am starting with a bigger numeral and then the smaller ones, how do I calculate that? That should be easy. And step three will be define how the reverse of addition, maybe it's not going to be addition anymore, right? The subtraction works. Okay, so I have three steps that will help me solve this problem. I will start with number one. Let's tell Python what exactly Roman numerals mean, because we will need that. So let's just do it right there. I'm just going to call it Roman map, and my Roman map will be a dictionary of Roman values. So I in my dictionary will equal to 1. And I'm just looking at this guidance here. Literally, I'm translating what I can see on the screen into Python. V will equal 5, which is fine. And then x equals 10. And you can see that I'm not really good with Roman numerals. L equals 50. And then C equals 100. And we've got two more. D equals 500. And lastly, M equals 1000. Romans were very smart. This is amazing. Okay, I've got the Roman map. And if I run this, now I've got Roman map in the memory. Okay, now that we have the Roman map ready, I'm just going to run it. And I'm just going to show you what it looks like. Not sure if you have worked with dictionaries a lot before, but the key and value pair are going to save our lives. Because with a Roman map being a dictionary, I can just call each Roman numeral and find the value for it. For example, if you're looking to understand what is the value for L in Roman numerals, you can just call it from Roman map dictionary and find the value. This is very, very helpful because imagine the user gives us a string, because the user will give us a string format that's from Leetcode. And they tell us, hey, what is the value of this S? And all I need to do is to say, okay, Roman map, can you tell me what is the value of V? And it says it's 5. So the user has given me 5. Also, if the user gives me a bigger number, for example, if the user says S equals V triple I, which would be 8, I will have to do a bit of work here. So let me show you. I'll run S equals 8 in Roman numerals. And I'm just running you through the thinking, and I have not really worried about, the step 3. I'm just thinking step 2 right now. For this, I would write a for loop and say for a character in S, which if I print it, you will see that character is VIII. All I need to do is to go to my Roman map, right? And take that character, and let me just see if I can print that character. I just want to see that if I can show you the values. You now see that V is 5, I is 1, I is 1, and I is 1. So I'm just printing them one by one. If I get rid of this print character, you will see that I have the values. All I need to do now is create an empty bowl or an empty bag, if you like, and keep adding to it. So let me call my empty bag the result. And at first, the result is 0 because we're starting from 0. We're just getting the user's input and start adding it together. So every time I take a new character, I have to put the value of that character into the bag. That's what I will do. Let me open some space here and say result at each round equals the result from the previous round plus the Roman map for that character. So let me run you through how this for loop works. It takes the first character, which is V in the first place, and says, okay, what is the value in Roman map for V? It looks in this Roman map and says, okay, V is 5. All right, this is 5 now. This is 0 because we set it to be 0 in the first place, and now 0 plus 5 result becomes 5. Next time around goes back up. What is the next character? It's I. It says, all right, what is the Roman map value of I? It is 1. And this used to be 5 before, so 5 plus 1, and then the result is 6. And does that for the next two i's, and the result at the end should print 8. Let's see what the result looks like. And you can see that at the end, it becomes 8. If I get rid of this, you will see that the result is 8. So we literally did step 2 just above here. So what I will do, I will move this after step 2 so that we have done it. Okay. Now, the only bit that we have to do now is to look after any time that one of these Roman values is smaller than the next one, because we had some exceptions to work with, and I will work around that now. Let me choose an S that has got, for example, I and V. What would a human brain do in this case? So I would say at this point of time, all I have to do is to go to my Roman map and find the value of I, right? That would be number 1. And then I also need to go to my Roman map and find the value of V. And at the end of the day, I would have to say the result will be Roman map. So the value of V subtract Roman map value of I, right? This would be the result. And at the end, if I print the result, you will see that it will be 4. So how do I formulate into Python syntax that actually works? So to begin with, I will have to write a for loop anyways. For character in S, right? If I print character, you will see that it is I and V. And I need to set 2 different things, and I will tell you why. One of them is result, which is 0, and one of them is I, which starts at I. I want to use that I to move between the values inside S, because I don't really have a handle to move around and say, oh, is this one bigger than or smaller than this one? I am going to use that I to move between these characters and check which is bigger, which is smaller. That's what I'm going to use it for. All right, so I've got to this for character in S. What I'm going to do now, I'm just going to write a if statement. The if statement will have 2 conditions. They are very important. One of them is that I don't want to go outside the length of the S string. That is very important. So this is very easy. I will say if I plus 1 is smaller than len of S. I just want to make sure I am within the length of S. And my second condition, I want to check whether what I'm looking at has a smaller Roman value than the next one. So literally what I said. So I will say Roman map of the string sitting on index I has to be smaller than Roman map of the index I plus 1 within S. So that's what I'm going to say. I'm just going to say would be within the length of the string, and also make sure one of the first ones is smaller than the next one. That's the reverse order, right? Now, if that's the case, all you need to do is to say result equals result minus the Roman map of S for I. For example, if I translate this into what we were going through again here, for a character in S, what it will take first time I, okay? If I at the beginning is 0, so if I, which is 0 now, plus 1, makes it 1, is smaller than length of S, which is 2, yes, that holds, and Roman map of S of 0, so the value for I is 1, is smaller than Roman map of V, which is 5, yes, that's correct, so this is a yes, then this will run. The result will be the result minus value of Roman map for that actual character. So if I run this, this shouldn't be I, this should be plus 1, and I can print the result, and you will see that it comes back to -2. It's only because I haven't considered the next bit, because what happens, it comes here and says, yep, this is smaller than this one, and performs the operation. So once I have figured out I need to move on to V, which goes back to normal. Just normal means that V is smaller than its next, which is nothing. So I need to bake in step 2 into step 3. Let me copy that, and I will say else. And I have to change this to S of I. Once we go through I0, we need to add 1 to I, because it needs to just go to the next and go to the next and go to the next. So if I run that, you will see that the result for this specific use case is IV. So we've kind of figured this out. All we need to do now is to transfer this into Leetcode and see if it likes it. So I'm just going to copy that, and I'm just going to come back here, let me just move this window here so that I can paste my code. Just going to paste my code. This one has to move under there. And let me just indent all of this, which is cool. And all I need to do now is to say return result. And return result has to be also indented. So what I will do now, I will move my face to the other end, put it there. And now bring this one up so that I can see the test results. I'm just going to press this play button and see if the results are happy. Wait for it. It says, Roman map. I forgot to copy all of this. Sorry, you are right. I have to copy my Roman map. Otherwise, you don't know what it is. So go back up and paste it here. And I will have to drop this down, make sure this is indented, and bring this one back up and press play. All right, it says accepted. Case 1 is green, case 2 is green, and case 3 is green. If I press submit, let's see if all the cases are happy days. Yeah, it did say it is accepted. So thank you for watching. If you like this video, I would appreciate if you hit the like button, leave a comment, connect with me on LinkedIn, and subscribe to my channel. Thank you.